Today's lesson is on the formation of the solar system according to what we call the nebular hypothesis. Previously, we'd talked about the idea that all knowledge begins with a question. We have to wonder about the universe before we're going to be able to understand anything about it. And once we ask a question, we can come up with a possible answer to our question, and we call that a hypothesis. Now, a hypothesis, remember, differs from just a guess because a hypothesis is an educated guess. That means that we don't pull it out of the blue, make up anything we want like we're writing fiction. It's actually based on our prior knowledge about the universe in general and about observations we make concerning that particular question. In science, remember, a hypothesis needs to be tested before it's accepted as being true. The test involves two steps. The first part uses deductive reasoning in the form of if-then, that's rationalism, to make an observable prediction. In other words, we say, if my hypothesis is true, if I'm treating that as an antecedent, then what's a consequent that I should be able to see in the natural world? And then the second step is to use empiricism to actually look for the observation that you predicted should be there. And if you find that predicted observation, then you have a reason for thinking that your hypothesis is actually correct. If you don't find it, then you have a reason for thinking that your hypothesis is incorrect or at least incomplete. Remember, that's the whole idea of logical reasoning, is to come up with reasons for believing that your ideas are correct. Now, of course, we talked about the idea that this process involves the logical fallacy of affirming the consequent, and so in order to build certainty, we have to use abductive reasoning, and we have to repeat the repeat the test many times. But once we do, we've accumulated sufficient reason for thinking that the hypothesis may actually be the way the universe works. And if that convinces many experts in the field, then the hypothesis is now considered to be a theory. So remember, a theory is a very well-tested hypothesis. In general, the point of any theory, the purpose of any theory, is to make sense of what we observe. Since science studies nature, the purpose of a scientific theory is to explain observations we make of the natural world. So you have a diagram similar to this, illustrating the scientific method, and this is what we're going to be using in order to try to come up with a reasonable explanation for where the solar system came from. We're going to go through the process of asking our question about nature, which in this case will be, where did the solar system come from? We're going to make general observations about the solar system. We're going to apply that to general knowledge that we can determine about space and about matter. We'll come up with a hypothesis, and that's where we're going to take this lesson to. In a future lesson, we'll look at how we tested that hypothesis to turn it into a theory.